let's take a look at question number 18. It reads, point P is on a directed line segment from point X, -6, -2, to point Y, 6, 7, and divides the segment in the ratio 1 to 5. Question, what are the coordinates of point P? Okay, so we're going to get started by taking a look at the formula for a segment divided in a particular ratio. Alright, so let's write down the formula first, and then we'll apply it to this particular scenario. Formula is as follows. If, let's say, point P, x sub P sub y sub P, let's say that's the coordinate, divides a line segment from A, let's say the first point A is x1, y1, a line segment from A, x1, y1 to point B, coordinates x2, y2. Let's say it divides this line segment in the ratio A to B. Okay, so if this is a scenario, then the coordinates of that point in the center is going to be, we're going to have x sub P is going to be x1 plus A over A plus B. So x1 is basically the x coordinate of the first point, which is A, and A over A plus B is a ratio of the distance from x1 to x sub P. So multiply that by the entire length to get the exact distance, x2 minus x1, basically the run because you're going in the x direction. And then y sub P is going to be y1 plus the same ratio, A over A plus B, times the rise, y2 minus y1. Okay, so let's apply this formula to this problem. So we have the first point, x1, y1, we're going from x to y. Okay, so we have x1, y1, let's call it the first point, is going to be point x, which is -6, -2. And then our second point, x2, y2, is going to be point y, which has coordinates 6, 7. And then the point in the, somewhere in the, between these 2 points that divides the segment, point P, xp, yp, that's what we're looking for. Okay? Now the ratio A to B in this problem is 1 to 5. Alright, so with this information we can specify exactly what each component are, and then we will plug them into the formula when determining the coordinates of x sub P and y sub P. Alright, so x1 is going to be -6. Y1 is going to be -2, as you can see here. And then x2 from the second point y is going to be 6. And then y2 is 7. Using the ratio, we can clearly see that A is 1 and B is 5. Okay, so let's find the x-coordinate of the point. The x-coordinate is going to be, let's rewrite the formula, x1 plus A over A plus B, basically the fraction of the entire length. The entire length is your run, x2 minus x1. Okay, so this piece right here gives you the distance from the original point, and when we add it to the x coordinate of point, the first point, what is the first point? Point x, it gives us the x coordinate of point P. Okay, so let's substitute. X of P is equal to x of 1, -6 plus A 1 over A plus B, 1 plus 5, times x sub 2, 6 minus x sub 1 minus 6. Now we're going to use the order of operations to simplify this expression. So we have negative 6 plus 1 over 6 times minus is plus, you slash and dash. 6 plus 6 gives you 12. Now you can plug this in your calculator or work it out by hand. We're going to do this by hand. We have negative 6 plus 12 over 6, which is negative 6 plus 2. Negative 6 plus 2 is 4. So that is the x-coordinate of the point between the segment that divides the segment in the ratio 1 to 5. Now we need to find the y-coordinate. Let's write down the formula for that. y1 plus a over a plus b times the rise y2 minus y1. Okay, so y sub p is going to be y1, which is negative 2 plus a1, a plus b, 1 plus 5 times the rise y2 is 7 minus y1, which is negative 2. Now let's go ahead and work this out. We're going to have negative 2 plus 1/6 times minus slash and dash as a plus 9. That gives us negative 2 plus 9 over 6. Now if you simplify this, you have negative 2 plus 3 over 2. You find the LCD by expressing negative 2 as a fraction, and then you times it by 2 top and bottom. Remember, denominators of fractions must be identical in order for you to combine them. Okay, so this combines to give you negative 1 over 2. So the coordinates of point P is going to be x, this is supposed to be negative 4 for the x, and then the y is negative 1/2 for the y. Let's write that again. So x is negative 4 and the y is negative 1/2. So the answer for question number 18 is option number 4. Okay, now that we've solved the problem, let's go over a visual way to basically understand what's going on. Alright, so I'm going to call this a visual approach. You can use this approach to solve the problem. Let's say you forget what the formula is. If you consider the visual approach we're about to use, then you can also solve the problem without any complications. Okay, so we have 2 points. We're gonna label the points. I'm not drawing it to scale. Okay, so the points are x and y. So let's just graph 2 points. So we have point x right here, and then we have point y, let's say somewhere over there. Okay, so point x has coordinates negative 6, negative 2 for x, and then point y has coordinates 6, 7. So this is the segment that we're talking about right here. This segment is divided in the ratio 1 to 5, and point P is somewhere in between these 2 points. So if it's in the ratio 1 to 5, imagine breaking this line into 6 parts, and then the first part will be where point P is located. Okay, and we don't know what the coordinates of point P are. So what we did in this problem is we split up the problem. Okay, we looked at the x piece and the y piece separately. Alright, so let's take a look at the x direction first. So for the in the x direction, we're looking at the horizontal movement. So this is the x direction. Alright, so the x projection right here will be split in the same ratio. Okay? So what we just have to do is calculate this length right here and add it to the x coordinate, and that will tell us the x coordinate of point P. So how do we calculate this length right here? We want to calculate the length from here to here. Okay, so that length is basically 1/5 of the entire, the length is in the ratio of 1 to 5, these two segments right here. So this length is going to be 1/6 of the entire segment. Okay, so since it is in a ratio of 1 to 5, here this portion is going to be 1/6 of the entire length. The entire length is going to be -6, 6 minus -6, which is 12. Okay, so that length right there is 2. So if this length is 2, and you add it to the x coordinate here, that tells you the x coordinate of the point P, which is -6 plus 2, which is -4. Okay, so remember, it's in the ratio of 1 to 5. So this is 1/6 of the entire length. Okay, so this is 2, and then if you look at this side right here, what do you think is going to be? It's going to be 5 times the first segment, which is 10. Does that make sense? It should, because 2 plus 10 is 12. Alright, so what we're doing is basically sharpening up this side, this horizontal projection, into portions according to the ratio. Okay, now the same applies to the y direction. So let's say we have take a look at the rise here. Okay, we're gonna split it in the ratio 1 to 5. That will, and then when we split it in that same ratio, we can use that ratio to determine how long this portion is right here. Okay, so what we're going to do to calculate the length from here to here is we're going to calculate 1/6 of the entire horizontal span. 1/6 of 7 minus -2. If you count from -2 to 7, you're going to have 9 units. Okay, 1/6 of 9, and that gives you 3/2. Alright, so that's how long this portion is. So this portion is 3/2, and the remaining portion is 15/2. And then when you add 15/2 and 3/2, you end up with 18/2, which is a total of 9. 18/2 is 9. Okay? Alright, so what we did in the work we showed earlier is that we took the y coordinate -2, and we added 3/2 to it. -2 is the same thing as -4/2. If you add 3/2 to it, that gives you -1/2. Okay, so this is just a visual rendition of the problem, just to help you gain a deeper understanding as to what the formula accomplishes via the computations that we just did.